Alright, so here is your asynchronous session for week 2. We're going to go over lesson 8, inverse functions. The objective by the end of this is that students will be able to identify inverse functions along with their domain and range. Students will be able to solve equations utilizing inverse functions. What is an inverse function? So an inverse function is a function that undoes another function, resulting in the original input value. For a function f of x, its inverse function is f inverse of x. So that is our notation for an inverse function. So it's very similar to like if we have an equation that we're trying to solve for x. Let's say we have x plus 3 equals 0 and we want to solve for x. Well, in order to solve for x, we want to take the inverse of plus 3, which is just negative 3. So it's just undoing what the operation is doing. We're doing the same thing with our functions here. So domain and range. Suppose the function f of x with domain d equals negative 25, 27 and codomain c equals negative 500, 650 is a bijection. Identify the domain and range of the inverse. So codomain, when it is a bijection, which if you don't know these definitions, they are in your key terms of lesson 8. If it is a bijection, a one-to-one function and onto function, then that means that our codomain is the same as our range. So this is the same as our range of our function. Now, for our inverse function, our domain of our inverse function is the range of our original. So that means our domain of our inverse is that negative 500, 650. The range of our inverse function is the domain of our original function. So that's negative 25, 27. So this is the domain and range of our inverse function. We just switched the domain and range of our original. So go ahead, pause the video, see if you can figure out the domain and range of your inverse for this problem, and then unpause it to see if you got it right. Alright, so now that you have had some time to do this, let's go ahead and solve it. So again, this is a bijection, so that is our range. So the domain of our inverse function is our range of our normal function, so negative 21, 20. And the range is what our domain was of our original, so the 600, 750. Hopefully you got that right. It's pretty simple. Just switch them. So now let's actually find the inverse. So the first step I'm going to do is instead of f of x, I'm going to write that as y. My second step is I'm going to switch my x and my y in my equation. So instead of y, I'm going to have x equals negative 16 plus y divided by 4. So now I need to solve this for y. So I need to first multiply by 4. So we got 4x equals negative 16 plus y. And I need to solve for y. So I need to add my 16, add my 16. So we now have 4x plus 16 equals y. And then the last step is instead of y, we're going to write our notation for our inverse and then write that equation. So that is our inverse function. Now our domain and range. So our domain and range of our original function, which if you don't know it just by looking at it, you can always graph it and look at it that way. So our domain and range of our original function are negative infinity to infinity and range negative infinity to infinity. So that means when we flip it, it's still going to be the same. So our domain and range of our inverse are still negative infinity to infinity, and our range is still negative infinity to infinity. And that's our inverse function. So let's do another one. So remember, first we're going to change that to a y instead of f of x, which are x and y. So we now have x equals negative y plus 1 quantity cubed. I need to get rid of this negative out in front, so I'm going to first divide by negative 1. So I now have negative x equals the quantity y plus 1 cubed. Now since it is cubed, to undo my cube, I'm going to take the cube root of both sides. So I now have the cubed root of negative x equals y plus 1, and then finally subtract 1. So I have that negative 1 plus the cubed root of negative x equals y. And then remember, we need to change it from a y to our inverse. So we get inverse. Our inverse function is negative 1 plus the cubed root of negative x. Okay? Domain and range for this one is the same for both the regular and the inverse again, just like it was before. So it's negative infinity to infinity and negative infinity to infinity. Alright, so go ahead, pause the video. This is a little bit trickier than the one that we've done, especially for the domain and range. See if you can figure it out. Alright, so now that you've had some time to figure it out, let's go through and solve. So your inverse, switch the x and y, so we get negative 2 over y minus 1. Add 1 to both sides, x plus 1 equals negative 2 over y. Multiply both sides by y, so we get y times x plus 1 equals negative 2 over just negative 2 because our y's canceled out. Then we're going to divide both sides by x plus 1, so we get y equals negative 2 over x plus 1. Change our y to our inverse notation. So our inverse is negative 2 over x plus 1. So this one's a little bit trickier. Of our original equation, our domain of our original equation is everything except for x cannot equal 0. And our range is everything except for y cannot equal negative 1. So that means our domain for our inverse is x cannot equal negative 1. And our range is that y cannot equal 0. So that one's a little bit trickier. Hopefully you were able to figure it out. So now let's use our inverses to actually solve equations. So we're given our function, and we want to know what value of a makes f of a equal negative 3. So we're going to use our inverse to solve this. So our inverse we found earlier of this equation is negative 2 over the quantity x plus 1. So since we want to know f of a equals negative 3, this negative 3 is our x value in our inverse. So we're going to plug that in. So we get negative 2 over negative 2, which reduces to 1. So a equals 1 to make f of a equal negative 3. So remember, our inverse for this function we also got earlier is 4x plus 16. And remember again, we're just going to plug this negative 9 halves in for x. So 4 times negative 9 over 2 plus 16. 4 times the negative 9 halves gives me, well, 9 times 4 is 36. 36 divided by 2 is 18. Negative 18 plus 16 gives me a negative 2. So that means that my a equals negative 2. Alright, let's see if you can do it. So go ahead, pause the video again and see if you can complete this one. Alright, so now that you have done it, our inverse function, remember for this one, is negative 1 plus the cubed root of negative x. We're going to plug our 8 in for x, so we get negative 1 plus the cubed root, negative 8. This one's a bit trickier. If you don't know the cubed root of negative 8, you can plug it in on a calculator and figure it out. Because we want to know, since it's the cube root, what number multiplied by itself 3 times gives us a negative 8. Well, that number happens to be a negative 2. 2 times 2 is 4, times another 2 is 8, and then if we have 3 negatives, that gives us a negative number. So now negative 1 plus a negative 2 gives us a negative 3, so a equals negative 3. Alright, so that is it for your asynchronous session. So your exit ticket is what are the steps for getting the inverse of a function. Remember, to get your points for this, you'll need to answer this question along with all the questions in the Google form to get your points. So go ahead and answer those questions in the Google form along with this one. It will be one of them in the Google form, and submit it and you'll get it. If you have any questions, feel free to contact me.